Hey, just trying to give you some information on how to take the limit definition of the derivative and what it really means anyway. So, what we're looking at is this. We have a function which is clearly not linear, and we are trying to take the slope. We're trying to calculate the slope here at A. So, what I've done is I've marked off 2 points on my function. I've marked off A, and I've marked off A plus H. Now, obviously, the only difference between them is they're H units apart, and H could be anything. 2, 5, 17, doesn't matter. Now, for each point, I've found the Y value, f of A, and for A plus H, it's f of A plus H. Now, this is very general, and I've drawn in the secant line. And if you remember from geometry, a secant is just a line that crosses a circle, or in this case, a curve, in two places. Now, the point of the derivative in this case is to find the slope of this curve. Now, being that the curve isn't linear, we're not going to be able to take the slope in the normal method. We're not just going to be able to use y sub 2 minus y sub 1, because, as you should be able to tell, the slope here, the slope here, the slope up here are going to be very different. So, I have my secant line. Now, ideally, what I want to do is find the slope of a tangent. Now, if you remember from geometry, a tangent is a line that touches a circle or a curve in only one place. So what I want is I want a tangent to the curve right here at A. So instead of the secant line, which very obviously has a positive slope, I'm going to be looking at a tangent which, looking at this diagram, may actually have a negative slope or a slope of 0. So the only way that I'm going to be able to get a tangent is to take these 2 points, A and A plus H, and squeeze them so they are really close together. So my goal right now is to get this H value to be as small as possible. And ideally, I want this H value to be 0. So I look at standard slope. I know that the slope of a linear function is delta y divided by delta x, meaning the change in y value divided by the change in x value. Now, for the function I'm looking at, my two y values are f of a plus h and f of a. My two x values are a plus h and a. So I'm going to simplify the denominator a little bit. And I see right here, I still have my f of a plus h minus f of a. That is the change in the y value. The h value is just h now, because obviously a minus a, they cancel out. So remember, my goal is to get the slope of a tangent to try and approximate the slope of the curve. So if I want a tangent, my h value has to be 0. Well, we can find, using limits, the approximation when h is equal to 0. So I say I want the limit, h approaching 0, of my slope function. Now, when we get into class on Thursday, we will actually do some examples using a quadratic function, using a cubic function. But for right now, what I really wanted you to get from the homework is to get an idea of why it is that we even use the limit definition of the derivative. What is the point? And what is it really telling us? Because, I can tell you, you could do derivatives all day long. I could show you the really easy way to do it. But if you don't understand what it means in context of a graph or in the context of a word problem when we're looking at them, real-world application, your ability to do the derivative really won't mean much of anything. Because when we get to the AP exam, it's going to be ugly. So, I'll see you in class on Thursday, and I hope this helps.